Hi, and welcome to another edition of Hacking Maths. Today, we're going to have a look at quadratics and the types of graphs that they have. Now, a quadratic can be written in three different ways. Now, if you have a look here on the screen, we can see the first way, which is y equals ax squared plus bx plus c. And this is what is called the y-intercept form. Okay, so this is the y-intercept. And why is it called the y-intercept form? Well, because if a quadratic is written in this way, what we can see here is that this last letter C is the y-intercept. So if I take my quadratic here, and even though I have a graph of it, and I write the equation of it out in the y-intercept form, so that'd be y equals x squared minus 4x minus 12. So let's have a look at our graph. And if we look over here, we can see the y-intercept is here at the minus 12. And if we notice in our equation, the minus 12 is the y-intercept that we have here. So that's why it's called the y-intercept form. The next way that we have there is the completed the square form. So let's write out the completed square form. And this is y equals x minus 2 all squared minus 16. Now, if we have a little look here, where does this minus 2 and this 2 and this negative 16 come from? So let's look at the equation first of all. If we notice here, it says x minus h. What this means is the equation always takes the form x minus h, so h is always a positive value. So if h is a positive value, that means the graph is shifted to the right by that number. So the coordinates, which is very useful, the coordinates hk is the coordinate of the turning point. So this is either the lowest or the highest point on the graph where it makes a turn. So it goes from a positive to a negative gradient. And so we can see there's only one place in that graph where the gradient changes, and that's at this point right here. So if we look at this point, what we find is the coordinate of this point is, we can go and see here is that we move 2 along and we are negative 16 down. Now I know what you're saying here is you're saying, but it says negative 2. The way the equation works is it says x minus and then whatever the h value is. So if this graph had moved to the left, it would actually say x plus a number, because it would be x take away that negative number. So we have to be very, very careful. So we can see here the 2 comes from the 2 from the coordinate, and the minus 16 comes from the lowest part down there. It's a little difficult to see that there, but you could see it from before. Okay, so that's where the minus 16 comes from. Now the last form here is, and we'll write that in black, is this here. So this was the completing the square. Oops, we were doing that in red, so let's go back and do that in red. So this second one was completing the square. And the last one is what I like to call the root form. And this is the form where the graph cuts the y-axis. Sorry, the x-axis, not the y-axis. It's where it cuts the x-axis. Okay, where y is equal to 0. So if we have a little look, I will write down what the actual answer to this is. It's in the root form, it's y equals x plus 2 and x minus 6. Again, if we look at what the standard equation is, x minus p, x minus q, this is where we've factorized and written it in a factorized form. So even though we're saying it's a root form, it is actually factorized. Okay, so that's factorized. What we notice here is we could actually rewrite this as x minus minus 2. Because remember, two negatives together make a plus, and our x minus 6. Now, what this means is we are looking for if we go for our numbers, we're looking for a negative 2 on the x-axis and a positive 6. And if we go across here, we can see here the graph cuts, the graph cuts nicely at negative 2 and at 6. Okay, so what we can see here is, just to recap, there are 3 different types of equations that we can use for a quadratic. We have the y-intercept form. And y-intercept form, it's called that because the graph, it shows in the equation where it cuts the y-intercept. And we can see that by the green one here. It cuts it minus 12. The completed the square form. Okay, so completing the square. It gives us the coordinates of the turning point. So either the minimum turning point, which is what this kind of graph has, or the maximum turning point. Okay, so it gives in the equation the coordinates of the turning point. So if we complete the square, we know a little bit more about the graph. And then finally, we have the root form, or the factorized form. And in this, as we said here, it takes x minus p and x minus q. And this shows us where it cuts the x-axis. And that's when y is 0, okay? So we cut the x-axis at minus 2 and 6, and we can see here from our factorized form, x plus 2, x minus 6. And that's actually our minus 2, and we can see our 6 there. Okay? So we just have to be careful. Now, why do we write these in different ways? Well, a long time ago, now before everybody had calculators and graphic calculators and fantastic pieces of software like GeoGebra or things like Wolfram Alpha, we had to actually do these things by hand, and you would have to sketch a graph by hand. And wanting to know these things makes it much easier to understand how the graph is. So if we can write the equation in 3 different ways, and it gives us more information about the graph, and that's why we do this. Okay, so that's all that we've got time for this. Check out the other videos that I'll link in the description about how to factorize, how to complete the square. Okay, all right, thanks.